Now as you are familiar with the acids and bases, now we are just going to start with the salt, right. So salt is formed by a reaction or a phenomena called as neutralization reaction. I think the name is cleared or you can say the process is cleared from the name, that is the neutralization reaction. A reaction will leads to the formation of the neutral substance. So here we go, see. So whenever we react with acid and base, we get to have salt and water. So this is how the salt is formed. So salt is formed at the cost of the neutralization reaction. But you know that this salt actually, we have different kinds of salts, right. So sometimes we have the normal salt, we have acidic salt, we have basic salt, we have mixed salt, we have complex salt, and moreover we have this thing, the acidic, normal, acidic, basic, mixed, complex salt, and we have double salt. So likewise we have different kinds of salts. So what do you first of all, like before we discuss these types of salt, what do you get to see in the neutralization reaction? So I will state an example, you will be clear from it. Suppose I have an acid HCl and I have a base, say NaOH. So what happens, this Na just replace H and just combines with NaCl, and H and OH just form the H2O, right. So that means there is a replacement of H from the acid and there is a replacement of OH from the base that occurs, which leads to the formation of water and the salt. Now what happens in the normal salt? So whenever like you can say all the H ions from the acid and all the OH ions from the base are just replaced, we just get to have the normal salt, as I have just stated here. So I will just write in again an example. Suppose another example, H2SO4 plus NaOH, we will get to have Na2SO4 plus H2O. As you are unable to see any H or OH in it, so that means it is a normal salt. It is there is a complete replacement of H ions or the hydroxide ions, H ions from an acid and OH ions from the base has taken place. That is why you just get the normal salt. But when we talk of acidic salt, you know that the partial replacement occurs. So just look at the board how. Suppose we have NaOH and I have HCl. Right. So that means it needs to that means it should replace its H and it should replace its OH. But you know what actually happens here, what we get is, suppose I will just take another example, suppose we take a sulfuric acid. Right. So what do we get to see, like when it replaces this, so there is not proper replacement of the hydrogen ion and we get to have NaHSO4 plus H2O. As in this salt you get to see H ions, and you know that if any substance contain H ion, so that means when it will dissolve in water it will definitely going to produce the hydrogen ion, and the substance which produce the hydrogen ion is just regarded as an acid. So that means it somehow the salt should be neutral, but in this case the salt is somehow acidic because it contains the replaceable hydrogen ion in it, and so that means there is not complete replacement has taken place because the acidic character just remain in the molecule. So that means it is an acidic salt. And now when we just talk about the basic salt, suppose I will just say it again with an example. Suppose we have this base and this acid, right. So that means this OH ions has to be replaced completely, but actually you know what happened. So if the reaction take place in such a way that we get to see the hydroxide ion in the salt, so that means it is a basic salt because improper replacement of hydroxide ion is taken place. So this is, that means the salt will have somehow the basic character, that is why it is called the basic salt, right. Now when we talk of the mixed salt is actually, like for an example, it is K4 FeCN whole 6, that is potassium ferrocyanide. So what you get to see in the salt, see K4 FeCN6, what you get to see? It this thing, then it has the, you can say, anion, more than one kind of anion and a cation in it. That means it is a mixed salt. Now when we talk of the complex salt, right, when we talk of the complex salt, suppose we have this CaOCl2, right. So here also we get to see the simple cation as well as the simple anion present. So that means it is a complex salt. And when we talk about the double salt, it is just formed by the combination of the more than two or more than two simple salts. For example, we have soda alum. So what is the formula for the soda alum? It is Na2SO4 dot Al2SO4 whole thrice and 24H2. So see, it is formed from two simple salts. So that means it is a double salt. Moreover, I have one more example for you, that is the potash alum. So what you get to see, again K2SO4, Al2SO4 whole thrice and 24H2O. So again it is formed from the two simple salts, that is the potassium sulfate and the aluminium sulfate. So they are just regarded as the double salts. So this is what I have shown you in this with the types of the salt, that it is not always that you are going to get the normal salt. This may happen that the salt contains the replaceable hydrogen ion, or it contains the replaceable hydroxide ion, or it is just formed by the combination of two simple salts, or it has the more than one acid or this thing cation or the anion in it. So any kind of salt can be formed depending upon the neutralization reaction which is taking place, that whether the ions are completely replaced or there is a partial replacement. So this is how, like we just state with the types of the the salts. Now when we just talk about this thing, as I have told you that it is a neutralization reaction, so you must be curious to know where this neutralization reaction, apart from the salt formation, where it is used. So you should know that this neutralization reaction is used to reduce the acidity of soil. You know that some plants grow well in the acidic soil and some grow well in the alkaline soil, as it just depend upon the demand of the plant which has to be grown. So but we have a method that we can just reduce the acidity of soil by just adding slaked lime to it. So when we add slaked lime to the soil, the acidity of the soil is just reduced. Moreover, you must have encountered sometime with the sting of the yellow wasp. So you know what the sting of the yellow wasp actually has? It has an alkali, right? So whenever that wasp stings you, just put when it bites you, you know that it has an alkali in it. So if you will just apply the acid over it, that is the vinegar, acetic acid, you will just get you can say a quick relief, because see, the acetic acid is an acid, and I said that it has an alkali in its sting. So obviously the acid and the alkali just react to form salt and water. Again, it is an application of neutralization reaction. And moreover, the sting of the ants and the bats, you know what they have? They have formic acid. See, the sting of the yellow wasp has the alkali, right? And the sting of the bats and the ants, they have the formic acid. So when you just apply the soap over that area, because soap is alkaline in nature, so when you have just apply soap on that area, so that means alkali will just neutralize the formic acid, and you will be getting you will get relief from that. Moreover, I just told you when we were discussing the uses for the bases, I told you that magnesium hydroxide act as an antacid. So again, how it is just acting as an antacid, or what is the phenomena behind, is again the neutralization reaction. See, when you sometimes the acidity in your body just increase, as you all know that in stomach hydrochloric acid is being secreted for the proper functioning of the pepsin juice, which converts which just act on the proteins, convert proteins into peptones. You all know that, right? But sometimes what happens, due to some reason, the acid effect just increase in your stomach, right? So at that time you feel uneasy. So we need to reduce that acidic condition. We need to reduce the production of HCl in stomach that time. So what happens? We take the antacid tablets that time, and you know that how that antacid tablets work, or what are they actually? They are actually the bases that I told you, that it is mainly the magnesium hydroxide. So what is the magnesium hydroxide? That means it is a base. So when we just take in the component of it, that is the magnesium hydroxide, just neutralize the HCl acid which is produced in the stomach, and we just get a quick relief, right? So again, this is an application of the neutralization reaction. Now, when we just talk about the salt, like we were talking about the salt, that how it is formed, how are the types. So, you should be curious to know more properties about the salt, right. So, I just want to discuss few properties with you, as we have done already in the previous topic, but still I want that you should be familiar with the properties of the salts again. So, see, salt are basically, the normal salts are neutral in nature, right, and but we get to see a different kind of salts, as I stated with an example. So, first property is that they are mostly, you can say, they are neutral, that is with pH 7. Second is that they are actually soluble in water. Most of the salts, they are soluble in water. That means when we just dissolve in water, they just get this thing dissolved to produce an acid and base again. Like I will state with an example. Suppose I have a salt, say Na2CO3. So, when I will add it into water, what is going to form? This Na is going to form its hydroxide, and this H in CO3 is going to form H2CO3. So, actually it is the reverse of the neutralization reaction. As you say, as you saw this side, that when acid and base react, they just form salt and water. But when we react salt with water, what do we get? We again get the acid and the base. And you know, this is something called as hydrolysis of salt. That means hydro means water, lysis means breakdown of salt. That means the salt get lysed by water. So, and when the salt get lysed by water, what products do we get? Obviously, we are going to get those products from which it is formed, and those products are acid and base. So, that is why just like as a result of neutralization reaction, we get salt and water, and as a result of hydrolysis of salt, what we get acid and a base. So, this is how you can say the second property is that most of the bases, the salts are soluble in water, and what they do, they just show the kind of hydrolysis of the salt. And when we talk about the what happens when we pass electric current, so most of the salt just get ionized, producing their respective ions. Like we have CuSO4, suppose copper sulfate salt. So when I will pass electric current through it, obviously it is going to dissociate into the copper ions and the sulfate ions. So the aqueous solution of the most of the salts, third property is that the aqueous solution of the salts are actually good conductor of electricity, or you can say they just get ionized when electric current is passed through it. Now, when we just talk about the nature, so we get to see there are different kinds of salts exhibiting different kinds of nature. See, few salts act as drying agent. Drying agent means they can absorb the moisture. They can just, you can say, they can like if we have the air which contains the moisture in it, so we have certain salts which can just absorb that moisture, making the air dry. So that means they are used as a drying agent, right? And you know, some salts, they have the property that when they are exposed to air, they just lost their water of crystallization. Like few salts, as you saw in this case, there was 24 H2O. So that means they have the chemically combined water. When we will just expose this salt, this kind of salts, like if I talk about washing soda, suppose washing soda is actually Na2CO3.10H2O, right? So when I will expose it to air, what happen? It will just like there is a heat around. So what will happen? It will just evaporate the water of crystallization, and loss of 9 molecules of water of crystallization. Not all the water molecules just get evaporated. There are few number of molecules of water of crystallization that actually get evaporated, and that loss of the water of crystallization when salt is exposed to air is called as efflorescence. So again, they act as a drying agent, as I told you, and the more other property what they show, that they show efflorescence, that is they lose somehow some molecules of water of crystallization when they are exposed to air. And you know, the other property, some salts are actually hygroscopic in nature. What do you mean by hygroscopic? Right, hygroscopic is that which when they come in contact with the moisture, they actually change their state, right? So this, or you can say they just make the film around it, but do not get its states changed. So they do act as hygroscopic also, and moreover they act as deliquescent as well. So see, the salts have a different kind of nature. We get to see a different kinds of salts. Some are deliquescent, some are just showing the efflorescence, some are hygroscopic, and some are used as drying agent. So this is the salt. Actually, I think it's clear to you that how the salt is formed, what is the salt hydrolysis, what are the types of salts, and what are the properties of the salts. So this is we have done with the salts now.